We move on to question 19, which reads as follows. A train travels at a constant speed. It takes 21 seconds for the train to completely cross a 445-meter long bridge. So let's just pause there and see, draw a little diagram. So here's a bridge. Let's just imagine this is a bridge. Okay, and the train is 445 meters. We'll do that just now. So there's a train here. It's entering the bridge, and then it leaves the bridge. And for it to cross, so imagine that this is the front of the train. The front goes all the way and it lands up here. All right, for it to completely cross, this was 445 meters. Then the distance it has traveled is from here is 445 plus this is full length here. This is when it comes out of the bridge, plus the length of the train, whatever that is. Okay, let's call that x. X is the length of the train. Okay, so we can say let x be the length of the train. All right, so it takes 21 seconds. Now, similarly, it takes 16 seconds to completely cross a bridge which is 320 meters long. So that this is a shorter bridge, so it takes less time. I'm going to just put it down like that. And this is 320. And it takes 16 seconds. And the length is still goes in and comes out. And okay, so so they ask you what is the length of the train in meters. Okay, so what do you have here? You have the length of the train, we've called it x, and the total distance that the train travels, at least the front of the train travels, is 445 plus x. And this is meters. And its speed is, it's a constant speed. So let's work out the speed in each case. They're going to be the same. So we should say the speeds are the same in both cases. So that should give us an equation, because you got the speed is equal to distance over distance over time. The speed times time is distance. This is a master formula that we use. In all these distance time problems. So you got speed is equal to distance over time, d over t. So you've got the first distance that the train traveled is 445 plus x all over 21. So this is the speed, the distance over time. You can see it's going to be meters per second, meters over second. And in the other case, this is the same speed as in the other case, where the distance is 320 plus x. That's the distance at the front of the train travels, the 16. Oh, sorry, why am I writing 61 again? Okay, so now you got an equation with one unknown, namely x. So let's solve for x. It's 16 cross multiply into 445 plus x. I'm going to work this thing out because you can't use calculators. In Olympiad problems, you're not allowed to use calculators. All right, so you got all these huge numbers. So when you multiply, you got 16x. Let's bring all the x's to one side. This is 16 times x. This is 21 times x. Is the same as 21 times 320 minus 16 times 45. And these are the numbers. I got a negative here. So it's actually, let's change the sign. It's 5x. I'm going to turn this thing around here. You'll notice this 5 goes into this, 5 goes into this as well. So let's take this 5 out. And I'm going to turn it around here because I've switched it around here. So 5 to 16 multiplied by 89, right? This is 5 times 89 minus 21 times 320. Well, that's 320 divided by 5. That is 64. Okay, I'm going to go up to the top there. So 5x is that. So what is x? X is equal to 16 times 89 minus 21 times 64. No calculators allowed. Oh, I'm sorry, it's the other way around. It's the other way around. No, okay, I've already taken the other way around. Okay, so you see, this is 16 times 4, the 64. So I can take out the 16 as a common factor. And it goes into this 89 times minus, and this 21 times 4, which is 84. You see? And 89 minus 84 is 5. 5 times 16 is 80. And this will be in meters, because this is the length of the train. Okay. See how it is. We don't have to multiply these big numbers. Just take it out and cancel the 5s. All right. So the answer to this question is the length of the train is 80 square meters. Let's check to see whether this is correct. Let's clear out all these. And there it is. You have, I did it in a very much shorter way, but I explained everything fully in this solution. So D is 80 meters. We call it D in that problem. Let's now go on to the next problem, which is question 20. What does question 20 say? A room contains 99 boys and 1 girl. We got 99 boys and 1 girl. Okay, how many boys need to leave? All right. So it's something about boys leaving, and we don't know how many. So let's give a name to that straight away. Let x be equal to the number of boys who leave. Okay, so x leaves. So how many are you left? 99 minus x. Boys. So that the boys make up 96% of the people in the room. The 1 girl is still there. right? So how many people are there in the room? Now, X people have left. Number of people in room is now 99 minus X plus 1. Okay, so there are 100, there were 100 people. You have 100 minus X people in the room. And the boys, the number of boys is 99 minus X. So you want to find out what percentage of boys are left in the room. So you got 99 minus X boys over the total number of people in the room after the X boys leave. That gives you 96%. That's 96 over 100. Okay, so here it is. You got your equation. All right, let's just cross multiply 100 times 99 minus X. Oh, by the way, you can cancel the fours here. 4 goes into that. 4 goes into this 24 times. So you have this is really 24 over 5. That'll help me to simplify the calculations. So you got 99 minus X multiplied by 25, cross multiply, equals 24 into 100 minus X. Okay, so you have that X is equal to 25 times 99 minus 24 times 100. I've taken the 25X and put it on this right-hand side, 25X minus 24X. And that's how I get X. And on the left-hand side, I've got this. Now, again, you have 25 as a common factor. 25 goes into 100 4 times. 4 times 24 is 96. You see, you don't have to multiply. You can just take our common factors. That's the power of algebra. 25 into 99 minus 96 is just times 3. So that is 75. So the number of boys that leave, X is the number of boys that leave, is 75. Okay, it's quite interesting. All right, okay. In the beginning, there was 99% of the people in the room, so 99 boys minus 1. And there were 99 out of 100. And yeah, you are saying it's 96% of the people. You might think that just a small number of boys will leave, but it's actually 75 boys leave. That's quite remarkable. Let's just check that the number of boys after 75 leave is 24, and 75 have left from the 100. So there are 25 left in the room altogether. And there it is, you got 24 over 25. Okay. So we've actually checked to see if this answer is correct, but I'm going to expose it anyway. And there you see it, X is 75. It's the problem is solved in exactly the same way as I have done it. Okay, so let's get on to the next question, question 21. Oh, this diagram is quite small here. I can't capture it. Let me see if I can. No, I can't capture it. Okay, it doesn't matter. I'll redraw it. The cylinder A has radius 8 centimeters. Let's draw the cylinder. I'm not going to draw a very accurate picture. So you got a cylinder. So let's just draw the base. It's a circular cylinder, maybe. Yeah, it is circular. You could have rectangular. Well, cylinder is always circular base. Okay, the radius is 8. So the radius of the circle is 8. And the height is 20. Okay, and there's another cylinder. Let me draw this thing a little bit larger. And there, in the other cylinder, the radius is said to be 4. The radius is 4 in this case. And the height is 30 centimeters. Okay, now the two cylinders are filled with water to the same height. So you've got, this is filled with water. Okay. And the height here is, well, we don't know what the height is. They do say the height is h at the end of the problem. Let's call it h. And this thing is filled with water to the same height. Okay, now when the water from cylinder B, this is your cylinder A, and your cylinder B, the water from cylinder B is poured into cylinder A. So this water here is transferred into the cylinder here. Then the cylinder A is filled to capacity. In other words, when you pour this water into that, this whole thing gets filled up. Okay, so let's just calculate how much of water there is in the cylinder after you pour it. And just remember the volume of any cylinder is the area of the base, which is circle, times the height. And there are a couple of cylinders. This water is a cylinder by itself. And there's a large cylinder, and this water here is a cylinder, and so on. So there are quite a few cylinders, and we need to work out the total volume. The formula for the volume is pi r squared times the height. So let's work out what the original water is. Original water volume is pi times r squared, that's your r, times the h, right? And then the final, after this other one is poured, is pi h squared. That's the original. But just remember that this thing is now added to this. So this is pi, and here it's 4 squared. The radius here is 4 squared. Radius is 4. 4 squared times h. That's the volume of the water here. And those two things together give you the volume of this A, because it fills it up completely. And that is pi times, still 8 squared, because the radius is still the same, but the height now is 20 because it's this thing. Full cylinder, the volume is that. So there you have it. You have one unknown, namely uh, h. So let's take out the common factor. You got pi h into 8 squared plus 4 squared equals pi times 8 squared times 20, or 8 squared plus 4 squared. I can take out 4 squared, so the 16 pi h, or you can cancel the pi's also. So it's 16h, and here you have 2 squared plus 1 squared, and here you have, I'm taking out 4 squared, so it's pi times 2 squared. Pi is out, 20. All right, so you got 16 times 5 is 80h. Sorry, this is all very untidy. Please forgive me for the untidiness. This is 16h, and it's just that. So you've got the 16s cancel out. So you've got 4 plus 1 is 5. 5h is the 5 cancels. So it's 5h equals 20 times 4, which is 80. And h is 16. Let me see. I don't recall this as some calculation error here. So let me just see what's going on. Yeah, it is 16. So, okay, let's just get back to this one. Yeah. So 5h is 80. So h is 16. These numbers were not so big. I could have done it mentally. So I could have, yeah, I could have written 8 squared is 64 plus 16 is 80. I could have, instead of taking our common factors, I could have had 80h. And yeah, I could have had 64 times 20. So I could have done it like that, but still there will be some cancelling because 20 will go into this 4 times. So you have 4h is 64, and you come back to the same thing. H is 16. All right, so that is the height of the water in each cylinder. It's the same height. Let's get back to this and confirm that H is 16. So here we took 64 times 20 over 80. All right, so let's get on to the next problem, which is question 22. Let's see what this problem says. Two identical rectangles. Oh, okay, so these rectangles are exactly the same. They've got the same lengths and they've got the same breadths. They measure 4 centimeters by 8, so it's 4 by 8. Just remember. Now I can put a 4 here. This is 4 here. Okay, and the other one is 8. Just remember that. They overlap like this. Determine the shaded area in centimeters. Now the shaded area is a parallelogram. So the shaded area is the area of a palm. Palm is short for parallelogram, area of a palm. And the area of a palm is base times height. Area of any parallelogram is base times height. Now, the base for this is, let's call this one here x. So the base is x multiplied by the height. The height is this, the height between the parallel lines is 4. So the base is 4x. That's it. That's a shaded area. So the problem is to find x. Okay, so this is x. Now, okay, we know the area. Can I work out the area of this triangle? Okay, this is 8. This is x, so this is 8 minus x. 8 minus x. Because the whole length is 8. Okay. But now, you see, these two triangles are actually congruent. You got, this is 90 degrees, this is 90 degrees, and these angles are the same. And you got a side is the same. So you got two angles and a side, and here you got 2 angles on a side. Right? So these two triangles are actually congruent. The sides, okay, so what does this mean? It means that the sides are the same. So this is 4, so this is also 8 minus x here. But in this case, the hypotenuse is x. The two triangles are congruent. Why? 2 angles and a side. So 90 degrees, so it's side, angle, side. No. It's 2 angles and a side. Okay, so it means that these hypotenuse are the same. So equal hypotenuse. We'll call it hypes. But the hypotenuse in this case is x. In this case, the hypotenuse by Pythagoras is square root of 4 squared plus 8 minus x all squared. So you got an equation because these two triangles are congruent. So you have this hypotenuse is x and this hypotenuse by Pythagoras. So let's square to get rid of the square root. 4 squared is 16. And here you have 8 minus x all squared. 8 squared is 64 minus 16x plus x squared. That's how you square a binomial. Square 8 squared minus twice the middle, which is minus 16x, plus the square of the end. This 4 is coming from there. And you'll see the x squareds, they cancel. If you bring the 16x to this side, you get 16 plus 64, which is 80. And then you get x is equal to 5. All right, so that is the side that we're looking for. So therefore, if you go back and substitute it into that, this is 5 times 4, which is 20 square units. Areas, you must write down square units. So this was a nice problem where you had one unknown x, and you got an equation by noticing that these two triangles are congruent, and therefore they will have the same hypotenuse. And when you calculate the hypotenuse, you see it's actually equal to 5. All right, so that takes care of that. Let's just check to see whether the calculation is the solution that I had. Let's just clear out all these things. Okay, so you have, it's 20, because the area is 20, exactly as we said earlier on. Let's go down to problem number 23. There is a sequence of 7 positive integers. From the third number onwards, each number is the sum of the 2 numbers directly before it. Okay, so let's write down this sequence. We don't know what the first 2 are, but they tell you, let's call it A and B. But from the third number onwards, each number is the sum of the 2 numbers. So this is A plus B is equal to the sum of the 2 numbers before it. And the same applies to this. The sum of these 2 is A plus B, which is A plus 2B. And the next one will be the sum of these 2. And the next one will be 3A plus 5B. Now I'm writing down all these things, but there are 7 positive integers. You got 1, 2, 3, or you still got one more. This is 5A plus 8B. All right. And the 7th number is 2025. So you got 5A plus 8B is 2025. All right, so what is the smallest possible value of the first number? So we are looking at the first number is A, and the question is, what's the minimum? The smallest possible value, minimum value of A. So I need to work out A. Now remember, they are all positive integers. So although you got one equation with 2 unknowns here, but there are only a certain number of solutions because A and B are positive integers. When you substitute positive integers into this, you need to get to that. So let's see. I want to put 8B on one side. I see 5 is a common factor, you see. So let's just take that, put the B's on one side and take this 2025 minus 5A. So you get 8B is equal to 5 into 405 minus A. Now, you see, 8 and 5 have got no common factors. So A is a factor of this. But there's another way of looking at it. You see, this number is a multiple of 8, and this is a multiple of 5. So this common number is not only a multiple of 8, it's also a multiple of 5. So it has to be a multiple of 8 and 5. So it has to be a multiple of the least common multiple. The least common multiple is 40. So this is actually equal to 40 times something. 40 times, let's call it K. Because it's a multiple of 8 and 5, it has to be like that. So you got A is equal to 5K. If you look at these two, and so A is equal to 5K. So immediately it tells you that you're looking for the smallest possible value for A. So therefore, the smallest value for K is 1, right? Smallest K is 1. So therefore the smallest value for A is 5. Now why is this is strange? So you have 8, yeah. Okay, so the smallest value for A is 5. Then you can work out B, but that's the answer. So this is the answer. Just to understand what's going on, if you put A equal to 5, you got 25 plus 8B is 2025. Bring the 25 to the other side, you have 2000. 8B is 2000, so B is 250. So your starting point will be 5 and then 250, and when you keep coming down, you'll come to 2025. But we've already solved the problem long before calculating B or anything like that. So let's see. I don't recall this. Um, so the smallest value of A happens is 5. So I've got something else which is somewhat similar. Oh, and there's your sequence. Okay, 5 and 250. And if you calculate, you'll come to 2025. So the trick here was in the end, we said that A is equal to 5 times an integer. And the smallest value of that integer, K, we know, K could be any integer. So K would be equal to 1. And that gives you the smallest value of A. Okay, so let's move on. The question 24. 4 envelopes are labeled A, B, C, and D. So there you got envelopes drawn here. 4 matching cards are labeled A, B, C, Ds. So these are called capital A, B, capitals envelopes, and the A's are put in here. In how many ways can the cards be placed in the envelopes? So you want to put these cards inside the envelopes so that each envelope contains exactly 1 card. All right, so you don't put 2 cards in the same envelope. And no envelope contains its matching card. What does that mean? That means A should not be put into that one. B should not be put into that one. So if you want to put these cards into these envelopes, in how many ways can this be done? Okay, I've drawn these pictures here for good reason, because I'm going to put the card A first. Right? Suppose I put the A, I can't put the A, small a here. So I'm going to put it here. Right? Now, once I put the card A in here, then what goes here? You could put B. B is allowed. The A can't be put in this first one. And C and D. Right, so A could be put in here, and then you have to have B, C, and D here. Or I could have had A here, or I could have had A here. So there are 3 possible positions for A, and in each position, I'm going to calculate how many scenarios you've got. Okay. Now you got BA. So you got C and D going here, but C is not allowed to be put in there. Let's just put these envelopes here like that. So C has to go in here, and D has to go in there in this case. So you got CA here, you're left with B and D, right? The D can't go here, so D has to go here. And here you got DA, and you're left with B and C. The C can't go there. It has to go there. So this takes care of all the possibilities where A is in envelope B. Okay, now suppose A is in envelope C. So let's fill in this one. So if I can put B here, I'm allowed to do that. And let's just see what happens. If I put B here, then C and D could be here, or they could be like this, DC. Right? So I can put C and D in either cases. That's allowed. Okay, so if A is here, I, I could put B, C, or D, but I can't put D here. I can only put C. I've taken care of B. I can't put D, so this is the only one. Now, if A and C are here, then you've got B and D are left. B can't be here, so B has to be here, like that. Okay. Now, if A is in the last position, then you can put the B here, but you can't put the C here. So suppose I put the B here, BA, and as before, I've got DC and CD. Right? I can't put the C here. I had to put the D here, and then I'm left with B and C. Now B can't go in here, so B has to go here, and that's it. I've taken care of where the A is in the second column, or the third column, or the fourth column. Those are all the three possible cases. And in each one of those, we calculated what the things is. So how many envelopes do you have? The answer is 9. I drew these diagrams in advance, uh, cheating a little bit because I knew the answer is 9. So I just wanted to see what the 9 possibilities are. All right. So that's an interesting problem. And that now takes me to the very last problem. Let me show you. Oh, this is a very complicated way. I advise you not to have a look at that. But these are the various possibilities. I have to change this solution. It's looking terrible. Okay, so let's get on to the very last problem. The problem number 25. So here you got two cyclists are riding in opposite directions of a circular track. Okay, let's just draw the track. The circular track. Okay, so you've got these two guys are on this track, but they are driving in opposite, or cycling at least, in opposite directions. Suppose they started here. And one travels this way, and the other travels this way. One rides at a constant speed of 2 meters per second. So imagine this guy here is 2 meters per second. So that's his speed. And the other guy travels at a constant speed of X meters per second. So this guy's speed is X meters per second. Right? The two cyclists pass one another every 30 seconds. All right, so the speed is 2 in 1 second, 2 meters in 1 second. And in 30 seconds, this guy would be traveling 60 meters. This is after 30 seconds. In 1 second, he travels 2 meters. So in 30 seconds, he'd be here somewhere. but they meet now. So this guy is traveling at x meters per second. In 1 second, he travels x, and after 30 seconds, he's traveled. So this distance here is 60, and this guy, yeah, it's 30, 30x, because he does x meters in 1 second. So in 30 seconds, 30x. So these two together, they give you the circle, the length of the track. So 30x plus 60 is equal to the length of the track. So the two cycles, they pass one another every 30 seconds. If the length of the circular track is greater than 200 meters, so you are told that 30x plus 60 is greater than 200 meters. What is the smallest integer value for x? So we need to solve for x. So 30x, let's bring the x to one side. 30x, and is the 60, if you bring it to the other side, you have 140. Divide by 10, and you have 3x is greater than 14. So you want to know the smallest integer value for x. See, so what integer will make, what is the smallest integer that will make this work? X equals 1 doesn't work. 3 is not greater than 14. X equals 2 doesn't work. But if you want, you can say 3x is greater than 14, so x is greater than 14 divided by 3, which is 4 and 2/3. So you want the smallest integer, which is greater than 4. 4 and 2/3. Smallest integer. And that we know. What is the smallest integer greater than 4 and 2/3? That's 5. So you see 5 times 3 is greater than 14. So in that case, when x is 5, you've got the length of the track is 150 plus 60, so it's 210. So if the length of the track is 210, they will meet after 30 seconds. All right, so that takes care of the last problem. And thank you very much for listening. We now have come to the end of the South African Maths Olympiad junior paper, which was written in 2025, right, in the second round. So there are two other recordings which will take care of the problems from 1 to 20. I think I started it at 20, 21 or 19 or something. So the other two recordings, you will see them also in somewhere there in the internet. Okay, thank you very much. We will now end our session.